Hello, everybody. Hello, JIC. My name is Andrejs. I am a quality assurance architect in Evolution. Today is my first conference. I'm a bit nervous. I count on your support. In Evolution, we build games like this. You may see some samples on our stands, on our booth on the 0th floor. Basically, this is the TV show studio, except for it's not somewhere in the TV tower. It's right in our office, and I used to build this game myself, partially both studio and testing the software part. Or like this. This is a 3D version of one of our most popular games for people who doesn't like the games to have some live elements, who prefer for games to be something similar to the games. So today I will tell you about the TestOps in Evolution, how it evolved in the past 4 years. Like every bird likes its own nest, I will be speaking mostly about the QA side of this. Hope this is exactly why you came here for. And another disclaimer, I will speak mostly about the front-end part of the development. But I would like to start with a story. Once upon a time, there lived a grumpy developer. He had a very lot of work to be done. He never had a chance to do something else. He was busy with fixes, with dealing with broken environments, so he was struggling a lot. This is how the pipeline looked like. I didn't have much time to scale and color it properly, but this will work. So the developer writes the code, merges it, and then tests are executed on the dev environment. So if something is wrong on the dev environment, it means that environment is broken. Sometimes it's so broken that nobody can use it, and things got really tense because the work is freezed for everybody else. And the developer needs to start over with a fix, create new commit, merge it, run the tests again, and so on. If everything is fine, the release version is being prepared and release tests are being executed manual and automatically. Most of the time this was done twice, one for mobile layout and one for desktop layout. And again, if something is wrong, the developer needs to start over with a fix, make some cherry picks, and then make sure that release version is ready for next steps. Again, from the very beginning. It seemed that everything was working in usual DevOps cycle. So we write code, we build it, we test it, and we release it. We operate and monitor. We look how our environment works. But something was not really working. Of course, the developer was not the only one in charge of this cycle. There were also tester, ops engineer who helped him to try to make this setup stable. There were product owners, process masters, BAs, and so on. A lot of people, and everybody were grumpy. They had the tests, but the tests and monitoring systems which alerted if something is wrong, so they could change something. But most of the time, this monitoring system looked like this, which does not bring too much sense. So they were constantly working on improvements. The developer was trying to find ways to cover some significant areas with unit tests. Tester tried to save some seconds or minutes during the build to run tests faster and get the feedback faster. The ops engineer was juggling with configurations, trying to build the environment in the way it would not fail so much. But still, they still worked mostly in silos. Stumbling in the left part, the dev part. When after the test you cannot release, you should do the code again to fix some issues. Everybody was grumpy, and I was there too. So while at that time I could not imagine how the things would go further, now I can tell you, share with you our actions, what has been done, and what results there are. When we look retrospectively now at all the things that were happening back then, we see them only as consequences of a real problem. But first of all, let's fresh up a bit what does DevOps stands for. Ernest Miller stated in his blog post in 2010 that practical definition of the DevOps is an ops and development engineer participating together in lifecycle. To me, I feel something is still missing in this definition because in our setup we were also working together, but the setup had similar lifecycle, yet something was not working properly. For the DevOps, I like more the definition from Jez Humble, who wrote a few really cool books about the DevOps itself. He treats DevOps as a cross-disciplinary community of practice to study of building, evolving, and operating the systems. Let me tell you the difference. This is how the pipeline looked back then. If noticed, the tests are stored separately. They're written in Java because Java was also used on the backend side. But in setup like this, it's not possible to run tests before merge. Different languages, different build systems. And as we know, the QA, as we QA know, the cheapest bugs to be fixed are the bugs that could be found in the documentation, because not a single line of code yet had to be written. So you can just change the specification to avoid those bugs from happening. And the end-to-end tests are usually the most expensive one, because you need to write this code, you need to build this system, you need the infrastructure to deploy the testing environments. So the bug would be discovered only at the very late stage. At that time, the proposals to build tests inside the code, together with developers, like some unit tests, to make them running as early as possible, were often met with phrases like, QAs would definitely break our repository, they must use their own repository, and they should not use ours. I see smiling faces. Not only me heard such phrases, yes? Some of the QA engineers were refusing to think about putting hands to TypeScript to try write some unit tests, or maybe to check how the developers are working. Because why change something we are used to? So we're okay with Java. We have a lot of tests. We have a framework that's working. We don't need this. For some humble requests to work together on unit tests, again, like to start reviewing, let's start review merge requests together with developers. The developers used to answer, QAs would not understand my code, so why should we do this? And my personal favorite one is, you will need 3 persons to understand my code. I mean, if something needs 3 persons to understand, I bet you are doing this wrong. Hope this sounds silly. I believe you have the great collaboration with your team members right now, but I know that still there are engineers with such mindset. With attitude like this, it's kind of hard to communicate the new changes, to try something new, to convince your fellow teammates to try something new, to change approach, work on some improvements when one side isn't just responsive enough. Looking again at Jez's definition, I would like to highlight here the part of the cross-disciplinary community of practice. Working together doesn't mean working on one thing. I support an idea that DevOps is a subject of a cultural change in the first place. The same goes for the TestOps, respectively. Such cultural change is something that motivates people to share the information, to share the opinions, to try to experiment, invent new approaches. Usually such activities are described in relation to the community of practice, which is a group of people who share a concern or passion for something and they learn how to do it better. So it requires a lot of more interaction and open-minded attitude to deal with such things. So the thing with TestOps, like we now looking at the DevOps lifecycle, the thing with TestOps is that testing is not only a part that happens after the build. In fact, testing is at the every stage of the DevOps lifecycle. I may call it the project development lifecycle. So it's not feasible to just run tests after code and build stage because that's too late when the problems could be found. There could be testing activities during the coding part, some linters, type validations, unit tests and integration tests. During deploy and operation, like checking that environment is ready to be used, to check that the build is testable, some mechanism to quarantine flaky tests, monitor resource consumption that tests are using. Basically, there is testing everywhere. And it cannot just be isolated to a separate repository. Now, most likely, you would like to say now, okay, that's nothing new, we know this already, but how exactly did you fix all that, all the issues I have described? In the one hand, in our case, it started with some changes in technological stack that were caused by some global changes in technologies worldwide. And on the other hand, some positions were changed, some new team leads came, and at some point of time, it happened that really engaged people, really interested, came together and said from different departments and said, let's implement some improvements to our tech stack. Nobody got fired or demoted, but still, it's just something like just the right people at the right place and time. About the big changes. Somebody has worked with Flash, I suppose. So the Flash was about to be decommissioned. The tech stack needs to be upgraded, needed some refreshment, which also helped us to carry out certain advancements, not only to development process, but also to the testing and the development lifecycle overall. So that was the rough plan. Not that everything was done at the same time, but the key moments still are the switch from Java to Scala on the backend side, the adoption of Storybook on the front-end side, and various enhancements to infrastructure and test planning and management. You know, that practice with release testing was really painful because for the team, and there was a dedicated team for release testing, it was a never-ending nightmare. They had to make 2 weeks of regression testing, and as soon as they finish, they start over with a new one, as soon as previous one is complete. One of the major goals, not only raised by the QAs or devs, but overall, it was to implement the continuous delivery pipeline so that every commit can reach the production after certain rounds of checks in time less than 2 weeks. So on the backend side, Evolution decided to get rid of Java in favor of Scala and the power of functional programming. The story about why did it happen this way is worth a separate conference talk from our backend architects. They are in love with functional programming. They are ready to speak about it for hours. And as the TypeScript got used more and more together with Java and Flash decommission, that helped to convince automation QAs to switch to TypeScript. It's still one of the languages used by the dev team, so it's possible to receive some help or guidance in case we don't know something. And JavaScript world is rich with testing frameworks that could be adopted and provide the same or even more capabilities as Java frameworks do. Those Java tests were mostly end-to-end due to their nature. They're written on a different language, built and executed separately. And we wanted to reduce the amount of those tests by moving them to the unit and integration level. This is something similar to testing pyramid here. No exact numbers. I only must say that majority of tests were end-to-end, and we wanted to get rid of them as much as possible. So now for the component, there are no strict rules, but now for each component we have, we try to stick to the principle not more than 5 end-to-end tests. So only the most crucial, the most important scenarios. And the S logo here refers to Storybook, which the front-end developers started to use to prototype game components. For those who doesn't know what the Storybook is, it's a tool that allows to render UI components of application, like this chip stack on the right side. It's rendered without the backend using some steps. It's rendered without other components, so we can check it in isolation from everything. So we transpose the majority of our end-to-end scenarios to integration test level, making them component tests on Storybook. And we agreed that developers would run those tests before merge, which is very cool, kind of convenient for them, because building a Storybook takes way less time than deploying the real environments, and allow to test those components independently from the backend. Now, for the infrastructure part, the Ops department could rearrange free resources they spend usually on packages preparation to release packages preparation, to create so-called on-demand environments. To reduce load on the common environment, not to disturb everybody with simultaneous environment usage. They came with a concept of building the front-end part with proxy on already deployed backend environment, like the dev environment. So, to be more specific, we can take a branch with some UI updates. We can build it and use the backend from dev environment that still lies somewhere else. So we are flexible in selecting components we would like to build for the front end. We can specify some specific version, for example, to check the backwards compatibility for only one component to other components. And for the testing, the build of such environment takes about 20 minutes. Not to wait until this environment would be built each time. We created a pool of such environments to be used. So, like in the morning, there are created 3-4 environments that would be taken to when the tests would need to run. This helps us to save time a lot. And on the QA side, we created an orchestrator that defines what kind of environments needs to be used and what kind of tests needs to be executed, because we do not want to run all the tests on every change. Also, I'd like to know that while we were creating this orchestrator, the QAs, we learned a lot about our infrastructure. And now the solution of the logic of how the pipeline works is fully in our hands. if before we used to call an ops guy to ask for some help with pipeline setup, now we can do this by ourselves mostly. We may call for help if something new or something broke that we cannot understand what. But still, a lot of work could be done without even need to call for the ops department. This is how the pipeline looked back then. Note the tests in separated repository and release stages. And this is how the pipeline was transformed. We started to use TypeScript. When developer merges code, the orchestrator decides should component tests be run on Storybook or should end-to-end tests be run on on-demand environments. If everything is fine, the code is merged. So in case any error happen, developers see that test had failed, not only the test that he created, but also the tests that were created by the QAs. And everything is fine. The deployment happened on the manual testing environment, and if again everything is fine, in a few days this version is deployed on production. So every commit that passes this pipeline could be deployed to production. In case there is some issue during the manual testing or before the deployment, we just abort this pipeline. We take the next one. It's not a perfectly safe system, but the amount of issues when the environment is becoming unusable due to some bug reduced a lot. Like some numbers here. For example, selecting what kind of test needs to be running all validation checks, both created by developers and testers, take about 6 minutes. And running tests, depending on the component size, affected component size, is usually from 15 minutes to 1 hour. So the more you change, the more test needs to be executed. But in average, it takes about 20-25 minutes, so developers are okay with that. They don't see this as really impacting their usual workflow. And deploying to production when everything is done takes like 30 minutes. Of course, there is a flexible part in this manual testing, but still it's way less than 2 weeks. We have these changes coming, like there are dozens of such commits during the day, so we may say that we are releasing around 30 versions every day to production. Returning to the features of TestOps, at some point we realized that without aiming too much exactly specific ideas like they are described in the books, we managed to cover actually a few of them. QAs are in partial control of the infrastructure, maintaining and developing the logic of pipeline, collaborate with dev team on test setup improvements, and we fight the flakiness together. We do merge requests together. We ask the developers to participate in merge requests reviews for the codes, for the tests, for the test code. Some challenges. Of course, not everything went smooth and easy, and after a few years we can still identify a number of major and minor issues to be addressed. First of all, we clearly see now that there is a lack of Scala expertise in the QA, because everybody got switched to TypeScript, and now not all the QAs fully know what's happening on the backend, what kind of test coverage there is, which results in lack of trust to backend tests a bit. Secondly, this setup was great 4 or 3 years ago, but every year we almost double our game portfolio, so now we need to support more games, more components, more features, more builds and runs. And we now see that it's a time to create a kind of new orchestrator or some new approach to pick the test that needs to be executed even more selectively. Because still, we do not want to run large test sets on small changes. Finally, and the most crucial problem we had and still fighting with this, and with this I'm moving to the talk summary, is the most challenging is to convince people to talk to each other and to contribute to cultural change in the team. Not to divide people to developers or testers, to manual or automation QAs, but to make people understand the principle that we are making the same product. Part of the crew, part of the ship. We're one whole, and there could not be such thing as developers repository. Constant collaboration and continuous education are very important for the TestOps cycle, and since testing is present at every stage of this process, it's also important to development lifecycle overall. In our very case, the participation in the community of practice helped DevLean to look closer at what we do, what tests are we doing, how we implement them. And now they are actively participating, proposing some improvements, how to run those tests faster, how to make the build more stable, because they know that in the end they will have to pass those tests. So they start to build new features. They started to build new features with testability in mind. The QAs became more familiar with the infrastructure setup, and instead of waiting for some ops guy to come and fix, we do not afraid to change the scripts ourselves. Well, maybe only sometimes to show a merge request for review. This was my story, how the testing operations evolved in evolution during the last 4 years. I would be happy to answer your questions. We have a small booth on the 0th floor, so you're welcome. Sorry? You're welcome to join, to come to us and talk about the testing or anything else. Thank you for your attention. Yes?
Yeah, okay. I'm interested in how you specify which tests should run after changes to particular components.
Mm-hmm. We divide those tests on the like we have common components, we have the game-specific components. So when we see the change set that comes to us, we can identify if this is a common component. We are including on the tests that include this component in their assertion. For example, in the screenshot. If the button is changed, we run only tests that have this button covered. And if it's something game-specific, we do not run the common components tests. We run only tests that are designed specifically for this game. Yeah, thank you. That's it. Again, meet me on the 1st floor. I will be here today and tomorrow, and on Sunday would be happy to speak with you. Don't be shy. Thank you for your attention.